Okay, last section for chapter 2. We're doing two variable inequalities, 2, 7. Let me grab my pen. All right, so what are we looking at here? We're going to graph linear inequalities and we're going to graph absolute value inequalities. So nothing new in terms of the shapes of our graphs. We're going to do lines and we're going to do absolute value graphs. But this time it's not just the equals, it's also the less than and greater than stuff that we're going to worry about. All right, so just one new vocabulary phrase for today, linear inequality. And let's talk about what that is. So linear inequality in two variables whose graph is a region of the coordinate plane that is bounded by a line. All right, let's talk about that. The word bounded meaning here, meaning that we have a boundary. So in this equation, this dotted line is our boundary. We either want all the stuff below it or all the stuff above it. Okay, either way, we're going to figure that out. All right, dashed boundary is like an open circle. That's not going to have an equals. Solid boundaries, like this one down here, is going to have an equal sign on it. All right? All right, so now let's take a look at where we would shade. All right, so we can try one of these. So here's how we're going to do these problems. We're going to start by doing our coordinate plane, and we're going to graph it just like this was y equals 1/2 x minus 3. Two important points. We've got our b, which is -3, so we're going to go down 3, make a dot. Then our slope is 1/2, that's our m. So from our dot that we made, we're going to go up 1, we're going to go over 2, and be right here. Now the question here, should this be a solid or a dotted line? We look back at the original. Does it have an equal sign? No, it does not have an equal sign, so no equal sign means we're going to get a dashed line, meaning we can't touch the line. And then we have to ask ourselves, okay, are we going to be shading above or below? And when we look at this, we're going to say y is less than. Remember, y is our height. If we're less than, we need to be below. So we're going to shade the entire region below this line. So our answer to this equation could be any point. Here's one, or here's one, or here's one, or here's one. Any point that's below that line would work if we plugged it in. Any point above the line, here, here, or here, would not work because then it would be greater than the y. All right, so that's how we graph our equation, our inequality. See if you can graph the inequalities for A, B, and C. Remember, graph them just like a normal line and then figure out where you're going to shade. All right, number 2, let's try a word problem here. At least 35 performers of the Big Tent Circus are in the grand finale. Some pile into cars, others balance on bicycles. 7 performers are in each car, and 5 performers are on each bicycle. So let's see if we can get an equation here. 7 are in the cars, and, the word and means plus. 5 performers are on each bike, so 5b. And then we know it's got to be 35 over here, equals 35, but at least. Does at least mean above or below? If I'm at least 35, I could be 36, 37, 38. So I can be above, greater than, or equal to. I could also be exactly 35. All right, I'm going to graph this one using intercepts, actually, just so that we can remember how to do that. And I'm going to graph bicycles here, and I'm going to graph cars down here. All right, for my intercepts, 7c equals 35. Divide by 7, and we get c equals 5. So I could have a maximum of 5 cars. For my bicycles, I would say 5b equals 35. Divide by 5, and we're going to get b equals 7. 2, 3, 4, 5, 6, 7. And I'm going to connect those two dots with a solid or a dotted. Look back up here. It's got an equal, so this is going to be a solid line. All right? And then where are we going to shade? We want to be above or below 35. We want to be greater than 35, so we want to be above. If you weren't sure, we could pick some point that was just floating out there, maybe 5 and 7. Let's test this point right here. This is 5, 7. If we plug this in, we'd have 7 times 5 plus 5 times 7. That's 35 plus 35, and that's 70. Is 7 greater than or equal to 35? Definitely it is. That point works. So then everything up here is going to work. We're going to shade the whole area. Shade everything above. All right? So that's your real world example. You're going to use that information here on 2A to figure this out. Also, this intercept thing might have been helpful back here on 1A, right? So on 1A, you might want to be able to rewrite that using your intercepts. All right, so try 2A and B. All right, example 3. So next thing, we know how to now do inequalities for lines. How about for absolute values? So we're going to graph this just like normal. Don't worry about the inequality at first. Where's our vertex? Our vertex is at 4. Remember, it's the opposite, so not -4, and 5. So we'll go right 4 and up 5, make a dot. And from here, what's our slope? Our slope is 1, right? There's a 1 out there, which means I'm going to go up 1 over 1 and up 1 over 1. I've got 3 dots. I'm going to connect them in a V. The question here is, should it be solid or dotted? It's going to be solid. I see an equal line. Okay, so I've got it like that. And now the question is, do I shade above these lines or below them? And so let's check it out. Y is less than, so we need to shade below the line. So it's going to be everything below both of the lines. So it's a huge area there. We are protected. Everything up here is not going to get shaded. So that's going to be your graph. Okay, let me do B for you here as well. And so I'm going to get -y. I'm going to get y by itself here. Absolute value of x plus 1. Got to put the -3 out by itself. And then I want to divide this by -1. So here's a trick. Remember, when you divide, you switch the inequality. And now I've got -x plus 1 minus 3. Let's go ahead and graph it. My vertex is at -1, -3 down here. And my slope is -1. So I'm going to go down 1 over 1, down 1 over the other direction, and I'm going to dash my lines. And y is less than, so where are we going to shade? We're going to shade below the dashed line, so we're in here. Okay, that's going to be our complete graph. See if you can do the exact same steps on 3A and B. All right, last one. We want to take the graph and go backwards and come up with the inequality. So we want to figure these out. So we've got lines and we've got absolute values. So start with the line. Y equals mx plus b is the equation for a line. Let's go ahead and see what we can grab. B is our intercept. It's crossing right there, so b is -2. Gotta figure out our m. I'm going to find another point that crosses exactly and figure out how much it goes up and how much it goes over. So let's see here. It goes up 1, 2, 3, up 3, and over 1. So that's going to be a slope of 3 over 1, or just 3. Okay, so y equals 3x minus 1. But where are we shaded? We're shaded over here. That's below the line. So y is less than 3x minus 2. And since it's a dashed line, we're going to leave it without an equals on it. And that would be our equation. Let's do the same thing for the absolute value here. So we're going to say y equals, where are we moving here? Our vertex here is at 3, 2. So we're going to say absolute value of x minus 3, remember it's the opposite, plus 2. And what's our slope? We go up 1, over 1. So our slope is just going to be a 1 on the outside. Or you don't really need to write the 1, because it's just, if you don't write it, it's still implying that it's a 1. All right, where are we shaded? We are shaded above the y and equal to the line because it's a solid line. And then we just fill in our equation that we already found. All right, so that's it for the examples. You've got one more understanding check to try. See if you can do that. And if you've got questions, make sure you ask in class. See you then.